Good morning, fifth grade. Hopefully, everybody had a great weekend. We're going to now start on the second half of chapter 12, 12-4. So let's see how we're going to find out where that information is located. Go into your Google Classroom, click on your classwork, scroll all the way down here to chapter 12. And then down here, you will find your notes for right here, chapter 12, lesson 4. Please open those up and follow along. So here we go. Let's see what we're looking at today. Today, 12-4, shape of data distribution. Now, remember we talked about distribution before. That is how the data is spread out. Okay, it's grouped in one area with a lot of distance between the data points over here. It's grouped over here, and there's less of the data points over there. So that's what we're going to begin looking at here. So we're going to look at the shapes first. Now, this can be confusing, so make sure you pay attention carefully. Okay, it says, describe the shape of the distribution. It says, data that are evenly distributed between the left side and the right side have a symmetric distribution. If you look here, this is what we're looking at here. As you see, this curve here, this curve pretty much is the same as is on the left as on the right. If I were to cut this right down the middle here, you would see that this side here is similar to this side over here. So we call that symmetric. That means that it's equal on both sides here. It says the distribution shown as a cluster of several data values within intervals of 10 and 12. So as you see right here, they're saying, okay, if we were to basically draw a curve over here, so we'd bring it up, down, and around, okay, we would say, okay, this has pretty much a symmetric, that it's pretty much even on both sides here. But as you notice, we have a cluster. This is what we know as a cluster. This area in here is where the data is clustered. That's where a lot of the data is focused at between our intervals of 10, 11, and 12. That's where our cluster is. But we also see we have some gaps. So you want to also understand what gaps are. Gaps are where there's no data at all. We have some data to the left. We have some data to the right, okay? But we have a gap here. So we have a gaps at 9. And also, if you look over here, we have a gap at 13. Now, the gaps 9 and 13 have no data values at all. So the value 10, okay, let's look at here. Right here, 10. This is our mode, okay? This is our mode here. So that is our peak because it is most frequently occurred our value here. So that is our mode here. Okay. Now, just to show you over here, let's look over here. I have some more information over here. Make sure you write this down on your notes. Okay. If we see over here, this is known as like a tail. Okay. You see a tail here. It's low, low, low. Then it starts to get bigger, bigger, and then skews down here. Okay. We call this skewed left. Okay, skewed left means there's not a whole lot of data. The spread of the data is very spread out over here. But as you can see, it's more concentrated. We have a cluster of data in this section over here. This is our mound, let's say. There's our mound right here. Okay, so this is where most of our data is clustered, and this over here is where the data is spread out. We call that skewed left. Now let's look on the opposite of that. Okay, if we have what's known as skewed right, okay, we call this our tail over here. We have our tail over here. And then as you know, it comes up, mounds up, which means we have our cluster. A cluster of our data is typically in this area right here. We call this skewed right. So let's look and see if we can describe all this information right down here. So it says describe the shape of the distribution. Okay, so is this symmetric? No, it's not. We don't have any type. I mean, if we draw, it's sort of like this and then comes down to like this. That's not symmetric at all. Okay, so it's not symmetric at all. Okay, let's see if we have some gaps. Do we have any gaps here? Yes, we have gaps occurring between 19 and 21 right here. So we do have some gaps. Is there clustering? Yeah, we do have some clusters here. If we look, we have a grouping, a mound, let's say, a cluster right here between 16 and 18. And then we also have another cluster between 22 and 25. And it does not look like there's any outliers at this point. If we'd have an outlier, maybe like way over here. Okay, so let's see what else we have here for the next example here. We're dealing with the length of bicycle trails. So take a look here. Look what we have here. We sort of have this tail over here, and then it starts going up, goes up, goes up, goes up, and then down. Okay, so this here is skewed left. We call this skewed left. Here's our tail over here. It's not symmetric at all. The right side is higher than the left. That's why we actually call it skewed left. There's a cluster. If we take a look here, we have a cluster here between 5 and 9. There is a cluster. Do we have any gaps? Yes, we have a gap here between 3 and at 4. Do we have a peak? Yes, we have a peak here at 9. Here is our peak here at 9. I forgot to mention there's a peak over here at 22 also. Look at that peak there, what occurs most often, and does not seem to be any outliers at all. We'd have to figure that out by finding the quartiles, IQRs, all that fun stuff. So let's continue on. Let's see what else we have here. So if we look here, number of visitors at a gift shop. Now, this one here, we're not looking at a dot plot, okay? What we're looking here is our box and whisker plot. So what we want to see here is look at the distance between these two data points here and this data point here and these data points in here and this here. Okay, so let's see. Can we identify any gaps? No, because we don't know what the exact data is. Can we determine any clusters? No. Can we determine any peaks? No. We cannot do that at all because it doesn't give us this information like in a line plot here. Okay, it just gives us our box in a whisker plot, our points here. So if we look here, we do see that it is equally distributed because this 25% is equal to this 25% in the length of these, and this 25% seems about the same length, and this 25% seems to be the same length. So we can say the data is evenly distributed. So since it's evenly distributed, we can say, hey, the data is symmetric because the right side looks like the left side and there's no outliers at all. So we can see that here. So if we go over here to the next one, once again, we cannot identify any gaps. We can't identify any clusters or peaks because we don't have the data that we would have in a line plot here. Okay, it's not symmetric here. As you see, this length over here is much larger than this piece and this piece and this piece. It almost, I'm guessing, sort of looks like we have a tail and may come up and down, but we're really not sure. So we cannot say if it's skewed right or left. We would just say, hey, it's not symmetric. And there's no outliers here. We don't see any of those little stars that we were looking at before. Okay, let's continue on down here. Measurements of center and spread. It says use the following flowchart to describe which measure of center and spread are most appropriate to describe a data distribution. Okay, so let's see, what are we talking about here? Is the data symmetric or not? Okay, is the distribution symmetric? So what we want to look up here, remember when we're dealing with symmetric, this side, the left side is going to be equal to the right side. It's sort of that shape that we said, hey, it looks like a bubble. It looks like a bell, let's say, okay? The left side is sort of equal to the right side. If it is symmetric, we have a yes. If it is symmetric, we use the mean to describe the center. So we have to go figure out what the mean is and go from there. Use the mean absolute deviation to describe the spread. Okay, you remember that mean absolute deviation. If not, you need to go back and look to see how we figured that out. If it is not symmetric at all, we have a no here. Then we use our median to describe the center and use the IQR, the interquartile range, to describe the spread, how it's distributed. Remember the center, okay? That's if it's a yes, we use the mean to figure out where the center of the data is. If it's not symmetric at all, we would use the median. You know how to find that. To see how the data is spread out, if it is symmetric, we got to use absolute deviation. If it's not symmetric, we got to use the IQR. Okay, so let's try some of these here. Let's go down here. It says, describe the center and spread of the distribution. Justify your response based on the shape of the distribution. Then describe the center and the spread. Okay, guys, here we go here. Okay, if we look here, the number of states visited. Oh, take a look and see what we have here. This looks like to be a skewed right. It looks going around here. Then boom, we have our cluster down and over. Okay, so this is going to be skewed right. So is it symmetric? No. When it's not symmetric, we have to find the median and the IQR. Okay, so let's take a look here. So what I did, I went through, found our median. The median was 12. Here's my median here. Here's my 12th one right here. So I went through, found my median to be 12. Then I needed to find my Q1. So I had to break this section up in here. And I found my Q1 to be 11. There was my Q1 and to have my Q3, go through all this information over here. And I am going to have my Q3 at 13. Okay, now remember, in order to figure out the IQR is Q3 minus Q1. 13 minus our 11 is 2. So the spread of the data is 2. So if we take a look here, if we were to describe it, it says the data are centered around 12 states. Okay, that's our median. If we see the data here, the center is at 12. That's what we were talking about up here because it's not symmetric. That describes our center. And then it says the spread of the data around the center is 2 states. So basically what you see here, here's our center point here. As you see, we're sort of spread 2 points to the left and 2 points to the right. This is where our cluster is. Okay, so that describes our spread of our data right there. So let's look over here. The swing heights, as you see here, this does look symmetric. Comes up, sort of as you see here, goes down. Each side looks to be even on both sides. This side looks to be the same as this side, so they are symmetric. Since they are symmetric, guys, oh, this is no fun. We got to find the mean. We got to find the mean absolute deviation. Okay, so let's figure out on how to do that. So as you know, to figure out the mean, we add up all these numbers and divide by 18 because there's 18 different data points here. So when I do that, when I add those up, I got 180 divided by 18. This is supposed to be an 18. Please fix that. Divided by 18 equals 10. So we know that our mean is 10. So you can see the center here. This is our mean. This is our 10. Now we got to do the mean absolute deviation. Remember how to do that? Okay, you have to take each one of these points and subtract it from the mean and do the absolute value. So 6 minus 10 is -4. Absolute value of -4 is 4. Plus, go to the next one. 7 minus 10 is -3. Absolute value of -3 is 3. So plus 3. You'll go through all of these points here. And then when you add them up, you have to divide by 18, add up all those points, divide by 18, you get a mean absolute deviation of 1.6. So basically, let's look and see how we would describe this. If we were to describe this here, it says the data is centered around 10 feet. Yes, this is our center point here. Then it says the spread around the center is 1.6 feet. So basically, it's saying, hey, we're going about 1.6 feet left, okay, and 1.6 feet right, and that's where our spread of our data is. So there's a lot of information here that you need to understand. You need to make sure you understand if it's symmetric, what measures of center do we use. Also understand that what symmetric looks like, left skewed, and right skewed look like. Know what your gaps are, what your clusters, and what your peak means. So after you've gone through all of that, make sure you understand how all these problems work. Get started on your homework, guys. So have a great day. Talk to you later. Bye-bye.